Okay. Okay. So solution. Solution. According to the data, you need to calculate partial pressures. Pressure of oxygen equal to pressure into solubility. So pressure already given, that is 1, into solubility of oxygen already given, that is 0.2, equal to 0.2. Okay, next pressure of N2 equal to same formula, 1 into 0.8 equal to 0.8. Is that clear? So then you can calculate, you can take this formula, that is the ratio between mole fractions of oxygen and nitrogen. XO2 upon XN2, you can take like this. Mole fractions of oxygen and nitrogen with respect to the pressure you need to take for this problem. Okay, so that is pressure of oxygen upon here KH, Henry's law constant of oxygen, divided by pressure of nitrogen upon KH of nitrogen. Okay. Yes. So now you can substitute the values. Pressure of oxygen, how much you got? 0 to 2. Henry's law constant for oxygen is 3.3 into 10 power 7. Okay. On next, pressure of nitrogen is 0.8. Okay. Upon Henry's law constant for nitrogen is 6.6 into 10 power 7. Understand? So we can also write 0.06 into 10 7, 3.3 into 10 power 7. And simplify this. To 2. So you will get 1 by 2. That means one fraction of oxygen is to fraction of nitrogen equal to 1 is to 2. Is that clear, all of you? Any doubt you have here? Just let me know. This is the thing you need to ask. I mean, you need to say. See this one. According to the data, okay, problem number 3, according to the data, air contains oxygen and nitrogen in the ratio 0.2 is to 0.8. That means this one explains about the solubility of nitrogen and oxygen in the air. Just remember. If Henry's law constant for oxygen and nitrogen are 3.3, see this, 3.3 into 10 power 7 torr, and the Henry's law constant for nitrogen is 6.6 into 10 power 7 torr. And also that pressure was given, that is 1 bar in the data. So you need to find out What is the ratio between mole fractions of oxygen and nitrogen? This one you need to find out. So, according to the data, we have solubility and pressure. So, we have one formula. In yesterday's class, I explained about these formulas. Once you check those formulas, okay? So, pressure of oxygen equal to pressure at STP into solubility. So you can substitute values 1 into 0.2 equal to that, you will get the value. And the same thing for nitrogen also. After that, you can come to here. After that, you can come to here, that is a mole fraction of oxygen and a mole fraction of nitrogen. That is here, see. You have formula with respect to the pressure, say pressure of oxygen upon this is what Henry's law constant for oxygen upon pressure of nitrogen upon Henry's law constant for nitrogen. Okay, so now you can substitute all these values. Then you will get the answer. Any doubt is here, all of you? Can I go to the next page? One more time, I'm going to repeat the data given. The quantity of CO2 is dissolved in 500 ml of soda water. When packed under 2.5 atm pressure and Henry's law constant is 1.67 into 10 power 8 pascals. Okay. So you need to find out quantity of CO2 he said. That means W you need to find it. Given weight you need to find out. So I'm going to solution. Solution. First you can take mole fraction of CO2. We can also say this is a solubility according to the data. Pressure upon Henry's law constant. This is one formula you already know. Pressure given 2.5 atm. 2.5 atm. This atm we need to convert into the pascal. Okay, so here I am writing 1 pascal value. Okay, 1.013 into 10. 5 into this one I'm going to substitute here instead of pascal. 1.013 into 10 power 5 upon Henry's law constant you already have in the data 1.67 into 10 power 8. Okay, so you can simplify this. 2.5 into 1.013 1.67 into 10 3. So if you can simplify this, you will get 1.51 into 10 power minus 3. This is the solubility of CO2 according to the Henry's equation. Okay. So now you can calculate number of moles of water. Why water we have chosen? That is the solvent. Sorry, this one you can take it as solvent weight. H2O you can. So now you can number of moles of water 500 ml upon given weight is the 500 ml upon molecular mass is the 18. So if you can simplify 27.78. Got it? So and then mole fraction formula once you write moles of CO2 upon moles of water. Here in the denominator, you need to ignore CO2. See this, I'm going to ignore. So directly, I'm going to choose number of moles of water. That's what I'm rubbing this, okay? Yes. So you can substitute number of moles of CO2 equal to X into number of moles of H2O. X value you already have here, see left side. 1.51 into 10 power minus 3 into number of moles of water. 27.78. So you can simplify this. You will get the answer 0.042. Clear, all of you? Clear? One more time I am going to explain. According to the data, you have solvent weight, that is 500 ml. In a solvent weight, that is 500 ml. This is solvent water. Okay. Yes. And then pressure equal to 2.5 atm. This 2.5 atm we are going to convert into the Pascal. Okay. So then Henry's law constant you have in the data, that is 1.67 into 10 power 8 Pascal. So now from this data you can calculate mole fraction of CO2 equal to P by kH. So now you can substitute these values, this one and this one and this one. Okay, 1 Pascal value 1.013 into 10 5. ATM converts into Pascal. Why do I convert ATM into Pascal? Because Henry's law constant in the form of Pascal. That's what I have converted ATM into Pascal. So then I will get X CO2 equal to 1.51 into 10 power minus 3. After that, I am going to calculate number of moles of water. I got 27.782. And then after that, according to the formula, mole fraction equal to, number of moles of carbon dioxide equal to X into NH2O, nothing but support. You can substitute. We'll get the so, quantity he is asking. This is the quantity. Got it, all of you? Any doubt is here? Let me know. Any doubt is there? I'm going to the next page. Yes, once you can take this formula, solubility S2 equal to S1 into P2 by P1. You can use this formula. Okay. All of you please write along with me. Then I will stop. Okay. S2 equal to 4 into 10 power minus 3 into 250 into 100, 250 upon 100. Okay. And then you can simplify it. You will get 1.0 into 10 power minus 2 kg per meter cube. So then you can calculate weight of dissolved gas. Weight of dissolved gas equal to S2 into volume. S2 you already have 1.0 into 10 power minus 2 into volume, that is also there in the data, 2.5 into 10 power minus 4. Okay, you can simplify. 2.5 into 10 power minus 6 is your answer. Okay, all of you, second exercise completed. Fifth problem and sixth problem you need to do as homework, and also remaining problems, ninth, eighth problems are the theoretical bits. You need to solve them. Okay, I'm going to wind up this session here. Uh, Please prepare well for Monday's exam.